Welcome to The Explainer. If you've been paying any attention at all to enterprise tech lately, you can feel it. Something massive is shifting right under our feet. And the research officially declares 2026 as the tipping point. That is the exact year AI stops just politely answering our questions and actually starts doing the work autonomously. Today, we're diving into Agentic AI and exploring how we get from this chaotic, sprawling experimentation phase to secure, enterprise-wide scale.
To really wrap our heads around this, we've got to completely rethink what an AI model actually is. There's a great quote from the UALM blueprint for healthcare that hits the nail on the head. Agentic AI functions as a teammate capable of multi-step planning and goal-directed execution. Think about that for a second. A teammate. An AI agent isn't just some static piece of software waiting around for you to click a button anymore. It's way more like a junior staff member. It's out there monitoring data, reasoning through complex problems, using external tools, and executing actions all on its own.
Okay, let's break this down, because the contrast here is pretty wild. Traditional AI, it's fundamentally reactive. It basically sits there waiting for your prompt so it can generate some text or summarize a meeting. But Agentic AI is highly proactive. We're talking autonomous monitoring and goal-directed action. We are literally shifting away from these idle, standalone chatbots and moving toward massive autonomous fleets, agents that run complex, multi-step workflows totally in the background while you focus on the big-picture strategy. So, here is our roadmap for the explainer. First, the era of Agentic AI. Next, blueprints of agent agents, and then industry workflows. After that, we'll look at the agent sprawl threat, governing the AI fleet, and finally, the adoption roadmap.
Section 1. Era of Agentic AI, the 2026 tipping point.
Section 2. Blueprints of AI agents inside the machine.
So, what's actually under the hood? At the core of any software agent is this brilliantly simple but powerful geometry, a triangle of perception, reason, and action. It's this exact setup that lets an agentic system observe its environment asynchronously, make logical decisions based on whatever its goal is, and then act entirely independently. It's built entirely on the principles of autonomy and true agency.
And right at the foundation of that triangle, we have the basic reasoning agent flow. It's actually pretty elegant. The agent takes a query, turns it into a structured prompt, invokes a large language model, maybe something like Amazon Bedrock, and spits out a response. Now, in this most basic form, it doesn't have memory or external tools just yet. It's more of a highly composable, stateless building block that acts as a logic engine for much heavier workflows.
But when you start stacking advanced capabilities on top of that basic loop, wow, things get incredibly powerful. You could add retrieval-augmented generation to give agents long-term memory. You can use tool-based function calling so they can talk to external APIs or run math. There are even computer use agents that use visual language models to literally see and control digital environments, like clicking around a web browser. Or coding agents that sit right inside an IDE, analyzing your code to write, test, and refactor the whole shebang autonomously.
Let's take the RAG agent pattern as an example to see how this builds. Instead of just relying on the static data it was trained on months ago, a RAG agent dynamically searches external knowledge sources right in the moment, like an enterprise vector database. It grabs those relevant facts, beefs up its prompt, and generates a response. So you're connecting the static reasoning of the model to real-world, fact-grounded intelligence. It drastically cuts down on hallucinations, and you don't even have to retrain the underlying model.
Section 3. Industry workflows. Agents in the wild. I really want you to let this statistic sink in. 30 to 50%. Enterprises deploying these industry-specific AI agents are seeing massive 30 to 50% productivity gains, right alongside 20 to 40% cost reductions in their targeted workflows. I mean, the economic imperative here is absolutely huge. If you're not deploying these digital teammates to handle complex rules, you are essentially handing a massive competitive advantage straight to the companies that do.
To really see how that value gets generated, let's look at some real-world use cases. In finance, an agent doesn't just send an alert about a suspicious transaction, it actually correlates the signals and autonomously blocks the fraud. In retail, predictive agents keep an eye on SKU-level demand so they can automatically adjust pricing and trigger reorders. Logistics? If an IoT sensor flags a port delay, the agent proactively reroutes the shipment and negotiates with backup carriers. And in healthcare, clinical agents are silently triaging cases and securely updating electronic health records, which is a total game changer for administrative burnout.
Section 4. The agent sprawl threat. When autonomy becomes chaos. Now let's hit the brakes for a second because we have to talk about agent sprawl.
This is the unchecked proliferation of autonomous agents. Think about it. As different departments spin up their own localized agents, you very quickly end up with duplicated tools, totally unclear accountability, and an absolute compliance nightmare. Imagine a hospital where agents are tangled up across billing, patient experience, and utilization management. A small optimization tweak by one agent can cause system-wide friction. And worse, their access permissions might stay active long after a task is done, leaving massive security vulnerabilities wide open.
So the really crucial takeaway here is this fascinating inverted U performance curve. Research actually shows that a small, specialized team of agents improves outcomes beautifully. But as soon as you deploy teams larger than 4 or 5 agents, performance actually starts to degrade. Why? Massive coordination overhead. Literally, simply adding more agents makes things worse. It blindly expands your attack surface for nasty stuff like prompt injection, goal hijacking, and privilege abuse.
Section 5. Governing the AI Fleet, the UALM Framework.
So, how do we fix this? Enter the UALM framework. This is a fully audit-ready, implementable blueprint built specifically for CIOs and CISOs. It basically gives you a structured way to oversee complex agent operations, resolve those cross-domain conflicts, and keep everything compliant, all without suffocating the localized innovation that makes these tools so useful to begin with.
Let's step right through the 5 layers of this lifecycle. Layer 1 is the Identity and Persona Registry. This guarantees absolute accountability by using non-human identity tokens. Layer 2 is Orchestration, which acts kind of like a negotiation engine between the different agents. Layer 3 is Context and Memory, strictly keeping sensitive data bounded so it doesn't leak. Then, Layer 4, Guardrail and Compliance. This is your runtime policy enforcement, complete with automated kill switch protocols if an agent ever goes rogue. And finally, Layer 5 is Decommissioning, an automated service that cleanly revokes those identity tokens the exact second an agent finishes its job.
Of course, you can't run a heavy-duty governance framework like this without robust infrastructure. You absolutely must have vector databases to act as the system's long-term domain memory. You're going to need LLM gateways to intelligently route tasks between different models based on things like cost or latency. And you need secure agent platforms to manage all your API and tool integrations across the broader business. It's the essential plumbing for the whole operation.
Section 6, the Adoption Roadmap, moving to production.
Now, to safely pull this off, organizations need to follow the Agentic AI maturity model. You start way down at level 1 with ad hoc single-purpose chatbots. From there, you step up into managed identities and integrated shared knowledge. Eventually, you reach level 4. That is a fully optimized multi-agent ecosystem where a central orchestrator is dynamically juggling priorities, resolving operational conflicts, and enforcing incident response with human overrides.
Climbing that maturity model takes a very disciplined timeline. Phase 1, pilot high-value cases. Start small. Single-agent proofs of concept in mission-critical workflows like fraud detection. Phase 2, build core infrastructure. Get those vector databases and LLM gateways online. Phase 3, scale to multi-agent systems that can actually orchestrate tasks across different departments. And finally, Phase 4, enforce enterprise governance with continuous monitoring. The golden rule here, you absolutely have to build your security infrastructure before you try to scale the agents.
I want to wrap up this explainer by leaving you with a really provocative question from the research. When your AI agents are out there autonomously orchestrating your entire business process, who is ultimately in charge? Unmanaged AI autonomy isn't just some quirky technical glitch. It's a profound ethical and governance problem. Getting to true scale requires disciplined oversight, crystal clear accountability, and rigorous lifecycle management. Thanks so much for joining me on this deep dive, and hopefully this helps you build smarter, safer, and incredibly effective AI fleets in your own organization.